Electricity. What is electricity? Electricity is a basic part of nature, and it is one of our most widely used forms of energy. Electric current is the rate of flow of electrical charges. That is, I equal to Q by T, where I is the electric current, Q the electric charge, and T is the time taken. An instrument called ammeter is used to measure electric current in a circuit. SI unit of electric current. SI unit of electric current is ampere, A. 1 A is equal to 1 coulomb per second. Small quantities of current are expressed in milliamperes and microamperes. 1 milliampere is equal to 10 to the power of minus 3 amperes, and 1 microampere is equal to 10 to the power of minus 6 amperes. Electric circuit. A continuous conducting path between the terminals of any source of electricity, such as a cell or a battery, is called an electric circuit. Electric potential difference. The electric potential difference between 2 points in an electric circuit carrying some current is the work done to move a unit charge from one point to the other. The potential difference is measured by means of an instrument called the voltmeter. SI unit of potential difference. The SI unit of electric potential difference is volt, V. 1 volt is the potential difference between 2 points in a current-carrying conductor when 1 joule of work is done to move a charge 1 coulomb from one point to the other. That is, 1 volt is equal to 1 joule by 1 coulomb, or 1 V is equal to 1 J C raised to the power of minus 1. Symbols of some commonly used components in an electric circuit. Some important information on commonly used components of an electric circuit is tabulated. Go through this table. Circuit diagram. Displayed here is a simple electric circuit containing a cell, switch, and bulb. It is tedious to reproduce such electric circuits. To save time and to avoid confusion, electric components like cell, switch, and bulb are generally represented with standard symbols. A diagram which shows how different components in a circuit have been connected using conventional symbols for the components is called a circuit diagram. Ohm's law. In 1827, a German physicist, Georg Simon Ohm, found out the relationship between the current I flowing in a metallic wire and the potential difference V across its terminals. This relation between potential difference and current is called Ohm's law. According to Ohm's law, the electric current I flowing through a metallic wire is directly proportional to the potential difference V across its ends, provided its temperature remains the same. Mathematically, Ohm's law can be written as V directly proportional to I, or V is equal to Ri, where R is the constant of proportionality called the resistance of the conductor. Electric resistance. The opposition or obstruction offered by a conductor to the passage of drifting electrons is called electric resistance. Ohm is the unit of resistance. The Greek letter omega is used to represent ohm. A conductor is said to have a resistance 1 ohm if a current of 1 ampere flows through it, when its ends are at a potential difference of 1 volt. Bigger units of resistance. 1 kilo ohm is equal to 10 to the power of 3 ohm. 1 mega ohm is equal to 10 to the power of 6 ohm. 1 gigaohm is equal to 10 to the power of 9 ohm. Factors affecting the resistance of a conductor. Resistance of a conductor depends upon the nature of the resistor used, its length, area of cross-section, and temperature. Electrical resistivity of a material. Precise measurements have shown that resistance of a uniform metallic conductor is directly proportional to its length L and inversely proportional to the area of cross-section A. That is, R directly proportional to L by A, or R is equal to rho into L by A, where rho is the constant of proportionality and is commonly known as the electrical resistivity of the material of a conductor, or rho is equal to Ra by L. SI unit of resistivity is ohm meter. Arrangement of resistors in an electric circuit. In an electric circuit, resistors are arranged either parallel to each other or in series. Resistors in series. Resistors are said to be connected in series if they are connected one after the other in the form of a continuous chain. Effective resistance of a circuit when resistors R1, R2, R3 until Rn are connected in series is given by the relation R is equal to R1 plus R2 plus R3 plus until plus Rn. Resistors in parallel. Resistors are said to be connected in parallel if they have a common positive terminal and a negative terminal. Effective resistance of a circuit when resistors R1, R2, R3 until Rn are connected in parallel is given by the relation 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus until plus 1 by Rn. Joule's law of heating. The law implies that heat H produced in a resistor is directly proportional to the square of current I for a given resistor, directly proportional to resistance R for a given current, and directly proportional to the time t for which the current flows through the resistor. Mathematically, the Joule's law of heating is given as H is equal to I squared RT. Electric power. Electric power is defined as the rate at which electric energy is dissipated or consumed in an electric circuit. The power P is given by the equation P is equal to VI, or P is equal to I squared R is equal to V squared by R. The SI unit of electric power is watt, W. Watt is the power consumed by a device that carries 1 ampere of current when operated at a potential difference of 1 volt. 1 watt is equal to 1 volt into 1 ampere is equal to 1 VA. The unit watt is very small. In actual practice, kilowatt is used, which is a much larger unit. 1 kilowatt is equal to 1000 watts. Commercial unit of electrical energy. Kilowatt-hour or kWh is the commercial unit of electrical energy. 1 kilowatt-hour is defined as the amount of electrical energy consumed in 1 hour when the rate of consumption is 1000 joules per second. 1 kilowatt-hour is equal to 3.6 into 10 to the power of 6 joules.